Okay, good morning, good afternoon, good evening, depending on where you're listening from. This is the CISCO CyberOps training for Tier 1 SOC analysts. This is a series 28 in number. We're in the 17th module, and my name is Victor, and I'm going to be your anchor for this training. Now, module 17 is attacking what we do. The attacker is going to be looking at several things, right? We want to be able to explain IP services vulnerabilities, explain how network application vulnerabilities enable network attacks. IP services. Earlier on, we talked about ARP, DHCP. These are services that run on our network that makes it susceptible for us to be hacked. A host is going to broadcast an ARP address resolution protocol request to other hosts on the network segment to determine the MAC address of a host with a particular IP address. The question is, if we are to communicate, how are we going to communicate? Most of the times we're going to be using MAC address. Most of the times we're going to be using IP address. For the fact that we're using MAC address and IP address, then somebody is going to assign such IP address to us. Somebody is going to assign such what was it called? Somebody is going to assign such rather our MAC address is going to be part of our system because that comes from the manufacturer. Okay. If that's the case, the question is that a threat actor can poison the ARP cache of devices on a local network. Don't forget, we are saying that you have different devices and they are going to have in their cache the MAC address and the IP address of every other person so that when they need to communicate, they know who is a particular IP address and who is another IP address. Now, because these PCs are going to cache this information, it then means that this information can now be poisoned. This information cannot be tampered with. Okay, so this is what an example of a IRP hash poisoning looks like. So, like I said, anytime you hear the words poisoning or spoofing, right, you should get to understand that somebody is trying to clone an IP address. Let me see if I can zoom this up a bit. Okay, so this attacker has a MAC address of EEEE all true, whereas this legitimate PC have a MAC address of AAA all true. It's 192.168.10.10. So there's a 10.254 on the network, which is an attacker. Now, this guy is going to be sending ARP requests. This is I need an IP address, or this is my IP address, and the rest to 10.1. Like I told you in one of the modules that normally the router is going to pick .1 and every other item on the network is going to pick subsequently. So you get a reply. Of course, it's going to come back and give the guy uh, this is what it looks like, and now understand your MAC address. It's A1, 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 A1A. And on this guy's cache, it's going to store the IP address and the MAC of this guy. You still have the threat actor there having its own original EEE all true MAC address. What now happens here is that because this guy have spoof, he has been able to identify the IP address and the MAC address of this guy. He can have say, right? And this guy is off. That's why I call it man in the middle. This guy is staying in the middle between this guy and this guy. So he's going to take the place of this guy. And of course, he will not be the one communicating to the server. So the server will see it as this particular stuff, this particular a PC on the network. And don't forget, you're not going to be the one to do this yourself, but a tool is going to do that for you. Either can enable DSNIF, EtherCap, Yersinia, but you need to understand the workings of what a man-in-the-middle attack looks like. Okay, DNS attack. Like DNS attack, for instance, the DNS server IP address for Google is 8888, right? Same thing applies to ARP, can also apply to DNS. Every either local server or network server or web server is going to have a DNS, is going to have a domain name server, and this can be poisoned. But like I said earlier on, a good number of properly secured applications, properly secured servers are going to actually mitigate most of these attacks. Okay, stealth. Anytime you hear the word stealth, understand that you're trying to do something that is uh not loud. And one of the ways is by fragmenting such kind of technique or such kind of message that you're going to be pushing up to the server. And there are several techniques. There are several techniques that are stealth. There are several techniques that are covert. There are several techniques that are not going to be so loud, right? For tools and persons and technology to be able to identify them. So one of them is fast flux. So threat actors use this technique to hide. That's why it is called stealth. They used to hide their phishing and malware delivery sites. The DNS IP address are continuously changed within minutes. So the DNS server is configured in such a way that the application is hosted in one place, but in order to confuse you, for you to be able to identify and say, oh, I know this IP address is in our threat intelligence database, it's a spoofing IP address. What do? They use the fast flux methodology or techniques. So that way it's difficult for a tool to be able to identify it and say, oh, this server is prone to attack or susceptible to an attack, or we are going to be down if we continue using this particular service. Same thing with double IP flux and domain generation algorithms. This one is very common. Malware to randomly generate domain names that can be used as reservoirs points to their command and control servers. So they just generate uh, what's it called, domain names, and persons that are not looking clearly will not be able to identify that, oh, these malwares. And the reason why they do this is so that they cannot be caught. They are going to hide their identity. Hiding your identity, it refers to you using stealth techniques. Okay, domain shadowing attacks, DNS tunneling, DHCP. I've talked about this earlier on. You have your DHCP discover, you have your DHCP offer, you have this DHCP request, and your DHCP acknowledge. So this happen on the DHCP server or the DHCP, or just on your regular router, because that's the guy that provides IP address for everyone. Like here, what's not going to be the issue? Wrong default gateway, wrong DNS server, wrong IP address. For everything good that we have going for us because of these protocols, because of the DNS server, because of the IP, the what's it called, the DHCP server, that can lead to vulnerability. Enterprise services. Now, if you run a website, you'd want to make sure that you're deploying HTTPS. That should be port 443. That's HTTPS, yes. To investigate web-based attacks, security analysts must have a good understanding of how the web-based attacks works. That's why it's good if you want to be a penetration tester, if you want to be a cybersecurity expert. Aside having a good knowledge about networking, you want to have a very sound and be able to deploy both networks and web applications. Pick up a skill in web development, pick up a skill in any programming language, and be good at it. That way, you're able to provide your service, your penetration testing service, your countermeasures, right? You're able to check up things and profile solutions. I can tell you from experience that even a website that has HTTPS can still be hacked. Don't forget, Forget, there's what we call defense in depth. Defense in depth is where you are having multi layers of security. So you're not just having because you have SSL. No, you're also making sure that you are imploring the OWASP top 10. We now have a 2021 version. You are mitigating against SQL injection. You're mitigating against input validation, wrong input validation. You're mitigating against several things. So you cannot just say, okay, because I have my website and it has SSL that I'm not going to be compromised. No, you can have a full-fledged website well secured by HTTPS and can still go down. I've rescued a good number of sites in that kind of light. Okay, we talked about this earlier on, informational successful redirection and client error. Use the best practices. This is about, I think, 2000 or 1000 plus pages. This project, the latest version, I worked on the project last week and we explored the OWASP project. So if you're going to try to protect IP application, or rather web application, this is the project you want to use, right? It's a detailed project that has for a web application all the things you need to do and how you can attack it and how you can make sure that you don't use most of the things that make your website to be vulnerable, right? Okay, malicious iframe. So this majorly JavaScript, HTML. So you could have an iframe, you could have a so an iframe would typically be something like this iframe. It's going to have something like this iframe, or it's going to be a script tag, and the script is going to have a source, right? So you don't want to have you don't want to have so people can embed a script, embed an iframe, and it contains advertisement and threat actors compromise the web server and modify web pages by adding HTML for the malicious iframe. So good web dev skills will help you protect your client against HTTP exploits. Okay, what else makes sense that we need to explain? Don't forget, like we talked about defense in depth, email security is very critical. So you don't just implement SSL, for instance, on just your main domain name. A wildcard SSL will make sense. Where should I write it? I should write it somewhere here. Let me reduce this a bit so I can write something down. Wildcard SSL to be able to protect both main domain, e.g. domain.com and mail.domain.com and several other subdomain names. So this is your domain. This is your main URL. This is your TLD, your top level domain name. So it can be .org, .com, .net, whatever, .us. Then this is a subdomain. So this mail. So you could be protecting your main site and you're not protecting your mail. Every cPanel, it can be cPanel, it can be a Ninja server, it can be an Apache server, it can be an IIS server, whatever type of server you're using. Developers, you want to make sure that you get to your email settings and enable most of the security features that you have there, right? Most panels have open source free tools that you want to use to protect your emails. For instance, you don't want to avoid spamish email, right? What you could do is that you have a blocker so that it's going to filter most of the emails before it hits the user. um you want to train your staff. Threat attack actors can embed malicious content in business files such as email from the IT department. You want to educate your staff on so that they understand that social engineering is real. Our staff can take the Google phishing test. It's a nice test that can help them abreast of latest email phishing tools that attackers can use. For web-based tools or web-based applications that have a database, severally we found out that several tools can discover vulnerabilities like tools like Bobsuit, like SQL Map, like Vega. Yes, this is on. I think this is still on Kali. If you don't have in Kali, you could download the project. This is a Python 2 project. It's a Python project. Then this is a vulnerability assessment tool. So don't forget, explore OAPs and try to start getting good. I recommend either PHP, Python, then of course SQL. These skills you need them to be able to mitigate this kind of attacks. Don't forget insufficient input validation. When somebody beats a website and is not validating input, right? Check out this OAPS project to help you learn how to better protect web application. Okay, so you see all of these things: code injections, SQL injection, cross-site scripting. All of these are more detailed. You have them in the OAPS project. Okay, this is a lab. This is also a lab. Okay, I think that's all. So attacking what we do, we get to understand that our ARP service, our IP service, our DHCP service, and our web services, they create room for attacks, right? They create room for attack. And what do we need to do? So ARP, DHCP, IP, and web services. These guys, they create room for attack, and we need to see how to mitigate them. For ARP, we want to make sure that we use very good, highly secured routers that we're able to catch up these guys. For DHCP servers, same thing. We want to be monitoring constantly. For IP, we can also deploy IPsec. For web services, we want to make sure that we deploy the OAPS project to better understand how we can secure our web applications as web developers. Okay, that is going to be all for the Cisco CyberOps Module 17, attacking what we do. Thank you very much and see you in Module 8.